All right, welcome to Lecture 10, Part 3. We're going to be naming binary acids, and oxoacids. So, a binary acid means it's just got two things. That is hydrogen and a non-metal. Okay, there are two significant exceptions to this. Okay, the first off is hydrogen plus oxygen is just water. And the other one is hydrogen plus nitrogen, which is ammonia. Okay. Neither of these is really an acid. Water is the definition for neutral, and ammonia is actually a base. So, neither of these counts as an acid, but the other ones do. And in fact, this is the source of one of our exceptions from naming covalent compounds. Remember, I threw H2S at you and said that its name was hydrogen sulfide. And that's because that's the rule for naming these binary acids. It's just hydrogen element ide. When it's not in water. Okay, acids are water soluble, and we have two different naming conventions. One is for when it's not dissolved in water. The other is for when it is dissolved in water. So not in water. It's hydrogen element ide. Yes, in water, hydro element ic acid. So this gives us two names really for every acid. Okay. Acid, dry, wet. So HCl goes from hydrogen chloride to that old favorite, hydrochloric acid. H2S is hydrogen sulfide. You toss it in water, it becomes hydrosulfuric acid. HF is hydrogen fluoride and hydrofluoric acid. So this is a fairly simple trend, a fairly simple pattern. I should hope it would be easy to remember. The real trick is to remember, you've got the H in there. That means you're dealing with an acid and not a typical covalent compound. Now, the other case is the oxoacids, or the oxy acids, and that is slightly more difficult. Okay. You still have a difference between dry and wet, but now the name of the acid is going to change slightly depending on what oxoanion is involved. Okay. So I'm just going to show you the chlorine series, because that will be nicely instructive. HClO, HClO2, HClO3, HClO4. So dry, hydrogen hypochlorite. Hopefully you remember that. Hypo because, it's got the fewest oxygens. Ite, and fewer oxygens. Hydrogen chlorite. Hydrogen chlorate, and hydrogen per chlorate. So when they're dry, we treat them like ionic compounds. Next up, we have when they're dissolved in water. Hypochlorous acid, chlorous acid, chloric acid, and perchloric acid. So first off, notice the complete absence of hydro. Okay, there is no hydro in front of the name of the acid. The name of the acid is just based on the negative ion here, and it's just the name of the ion, and then you change the ending. You know, ITE becomes OUS, ATE becomes IC. And this is for all the oxo acids. Okay? And that's where you get all of these, and a number of others. Among them, the quite famous H2SO4 is sulfuric acid. Okay? Notice the difference with H2S, which is hydrosulfuric acid. Similarly, we have H3PO4, which is phosphoric acid. Okay. And then you could have H3PO3, which would be phosphorus acid. And I want to go ahead and just to make it clear, H2ClO3 is chloric acid. HCl is hydrochloric acid. All right. So that covers your binary acids and your oxoacids. Okay. The tough part, I think, will be remembering what ends in "ite," what ends in "ate," and of course that "ite" goes to us, "ate" goes to "ick." So definitely keep those in mind. And just to make it clear, dry, you treat it like an ionic compound. All right. I'll see you again in the next video for the start of Lecture 11.